So this is not going to be easy because I have to do it with one hand, but I've previously done this, and so I've got my meter and my resistor. You don't have to use a specific 10 ohm resistor. I mean, anything that can put some sort of a load on it should be fine. You can use like a 12 volt bulb or something like that. You can put a bunch of amps on it if you want to, but to be honest, all you're doing is trying to discover which ones are really shit and which ones are okay. And what you're looking for is when you actually apply the load that the voltage drops, and how much and how quickly. And it's quite arbitrary. I've done it quite arbitrarily. Right, so let's start. Okay, sorry. So let's start with these ones I've separated because I already know that they're rubbish because I've already done it. Okay, and so what I'm going to do is I'll put the meter on. Now it's currently on volts at the moment, and I've got this connection on the same terminal. Just simply put it on the same wire. It's through the meter, so we know what current is going to be drawn. And then that's obviously the resistor, which is a 10 ohm resistor, and it can obviously take a bit of gadooby, so we're okay. And then this terminal is just going to the meter, and I've got this wire here, and I basically just connect it, and then we can see the voltage dip. Now this one is buggered. I know it's buggered because it's saying 5.3, and it's saying 5.3 because the pack is buggered, because that actually I charged it up, and I charged it up to a reasonable voltage, and it just won't hold it. So that's the reason why it's like that, right? So now you can see, now I'll put the connection on, okay, and what I'll do is when I connect it, you'll know when it does it because you'll see the voltage drop. So I'm connecting now. Look at that, 2.9 from 5. So that one's obviously rubbish because it's dropped too much. I'm only drawing, so this is 10 ohms, so I'm drawing less than an amp. Okay. Right, so the next one, let's put the next one on. Like I say, I know these ones are buggered. Right, so the next one is showing 6 volts, right? And I'm going to connect the resistor now, and you'll see it's dropping now. Yeah, that dropped down. Not that much, but it dropped quite, and it's the recovery as well, of course, but basically that dropped down from about 6.1 or 6.2 or something, and it's dropped below 5. Right, so that one's rubbish. We don't like that one. Right, the next one, so we're on third one down. Now this one's showing 8 volts. This one's a weird one, right? This is showing 8 volts. So if you actually check this, you'd be like, oh, it's 8 volts, it's fine, right? And I'm putting the resistor on now, and now you can see it's plummeting now. Yeah, down towards 6 volts. Now these have multiple cells, 1, 2, 3, 4, 5, 6 cells inside. My guess is that in this one of the cells is rubbish and the rest are okay, and that's the reason why it's like that. Okay, because it's not charging. So now what I'm going to do is move to the ones which are actually in reasonable state. Okay, now this one here is measuring 7.35, and I'm adding the resistor now, and you can see it dropped 20 millivolts, didn't it? 30 maybe, a few millivolts really, you know, not volts. And then when I take it off, it recovers, of course, but that's irrelevant. Okay, and then the next one down, let's put it there. Okay, and here we are. I put it on again, and you can see, you know, that drop again is 20 millivolts. Okay, and then we'll do the next one. Okay. 6.85. Now this is interesting because that's actually a low voltage, so this shows you now. I'll add the resistor in now, and you see how it's only dropped about 20 millivolts, 30 millivolts, which means it's just charged low. The voltage is low. Okay, it's dropping a little bit more. Yeah. Why is it at such a voltage? It's probably because it's just been sat. Okay, next one. Whoop, don't wobble. Okay, and this one's on 7.36, and I'm adding the resistor in, and again, oh, it's only dropped 10 millivolts. 20. So that one's actually pretty good, I would say. You know what I mean? It's even got 7.37, you know, was when I checked it. And it doesn't matter that these aren't fully charged. In fact, they're better not being fully charged, because that tends to, I don't know, nickel metal hydrides are probably better. 6.84, adding the resistor in. So that's 30 millivolts, 40 millivolts, 50 millivolts. That's not that great, but it's not bad. Okay, next one is okay, so what are we on there? 6.84. It's a bit weird. See, that one dropped. That's dropping a little bit too much for being comfortable, but it could be just because it's flat, you know. What are we on now? Next one down. Second from bottom. That's 6.15. Connecting the resistor, and you notice how it's only, it's not really dropping very far. Don't know, that's not that great, you know, but it could be just because it is actually quite flat. That's the reason why the voltage is dropping. Next one, 6.18. Adding the resistor in now. That's dropping a little bit, isn't it? But again, the voltage is low, so it's probably because it's down, it's discharged. Yeah. So yeah, that one's a bit low. So we had a few that were like 7, that one's 7.38, this one's 7.37. I think those ones are probably okay. So I would use those in a pack, right? But these ones are obviously, you know, cream crackered. Can't use them. They're just doorstops now. These ones, what we need to do now is actually charge them. And the way I charge them is basically I just put them on a standard power pack. Set the voltage to 8.2, you know, the voltage, and then set the current limit to like an amp or something, and then just let them charge. Let the voltage rise, and you can do them in parallel. I mean, you can. There's no reason why you can't charge them in parallel, because they'll all be maintaining the same voltage, and then bring them all up to the same voltage, and then check them again. Basically, check them to see what kind of discharge curve they have. You know. Yes, you can put a lot more current through them. I believe that the maximum current is quite high. Actually, it's like 100 amps for a few seconds. So that's where they tend to drop. But a bunch of these are actually okay, and I would reuse them. I just need to recharge them. I think that one and that one there, and perhaps these ones at the top are probably okay. And probably because they came out of a pack, and the only reason why they're out of the pack is because at the time we actually measured them, the voltage was lower than others in the pack, and so those were removed, and we were using we replaced them with good ones, tested good ones. But I think these ones are okay. Anyway, that's that.